Warzone-Workshops. I'm sure that the past three workshops have been not only insightful but also thoroughly enjoyable. Your enthusiasm and dedication truly make these sessions special. Now, on to a special announcement. Next week, Saturday, we have something thrilling lined up for y'all. A mini hackathon spans for 3 hours. For those who might not be familiar, a hackathon is an event where individuals come together to tackle a series of programming challenges within a set time frame. Don't worry if you are new to this concept. We'll be provide questions that cover the contents of the first 4 workshop sessions. Trust me, it's not as daunting as it sounds. Also, we'll be publishing the leaderboard on our social media platforms. And the top 5 performers will receive fantastic prizes sponsored by the Mathematics Society of the University of Mora. So, mark your calendars and don't miss out on this incredible opportunity. To be eligible for the certificate provided at the end of the workshop series, it's essential for everyone to participate in the mini hackathon. Many of you have been eagerly requesting the source codes from our past weekly HackRank contest. Well, I'm delighted to announce that those codes will be made available to you as well. Without further ado, let me introduce our esteemed mentor for today's session, Chatura Gunasekara from the 20th batch, Department of Computer Science and Engineering. He is currently working as a software engineer intern at WSO2. He has not only achieved success at the national level, but has also earned recognition on the international stage. So, sit back, relax, and get ready to soak in some invaluable knowledge from Chatura. The stage is yours. Over to you, Aya.
Thank you very much, Nadia. I'm audible and can you see me?
Yes, Aya, you are audible and we can see.
Okay. Good evening, everyone. I hope you are doing well. So let's get started with our session today. Right. Just 1 minute. All right. Let me share my screen. I'll turn off my video for now. So, right. Good evening, everyone. So today we'll start with file handling. So far, you have been doing what you have been following this course on Python and programming. And last week, if I'm not mistaken, you have learned about data structures such as lists, dictionaries, sets, and so on and so forth. And today we'll be talking about file handling. Right. Now, can some like we are all students here, so this will be an interactive session. I need you to answer my questions, and if you have any questions, you can raise those questions. I prefer if you use the meeting chat so everyone can see your questions and answers. Right. Now, what is a file? So what do we use files for? Can anyone answer this question? So up to now, you've been writing code, you've been getting inputs, and you'll be processing those inputs in some way, and you'll be getting some outputs. So what's the difference with that and reading and writing from files? Can anyone answer? Why do we need files? It's an easy question, and I hope everyone here, at least some. Right, store data. Very good. So what's the difference between, let's say, storing data in a variable in your program and writing that data to a file? What's the difference? So if you store data to a variable, so x equals a plus b, then x also have data stored in x. So what's the difference between storing? Very good. I prefer if you would put at as everyone. So the answers I got was the file is used to store data. That's correct, but it's not complete. A file is used to store data permanently. So if you close the program, still that data you write to a file will remain. On the contrary, if you use variables, once you close the program, the data you wrote is now not available to you anymore. Right. So now we'll talk about how we can interact with these files using programs. Right. So today we'll be using Python. Right. So there are three main operations that we can do with files. Okay. So there are these three operations. And I hope you can understand these two, read and write. So what is read? We open a file and we read the contents of the file. So when we open a file in the read mode, we can't write anything to the file. So this is important. If you open a file to read, you can only read, right? Then these append and write, they are both forms of writing to the file, right? So if you open a file to write, okay, we can write data to the file. If you open a file to append, the data we write to the file will be written from the end. So meaning that if you have something already written in the file, you won't override it, you will add what you're writing anew to the end of that file. So if I was to take an example, we'll do some examples as we move on. Right. So now I want you to do this session with me. So it's an interactive session. So open up your laptops and get the Python ideally running, and we'll do some this session is interactive. Okay, it's a very casual session and interactive session. You have to do it with me. Right. Now let me open a file. Let me open DLE and right. Give me 1 minute. Right. So right. Can you see the Python program that I'm about, right? Can you see my IDE? If you can put a yes to the chat or unmute and answer. Right. Very good. I hope you have your IDE opened up as well. Okay. So now, if I was to share my entire screen. Right. So now, this is my directory. Okay. So this is the folder I have opened up. And here, I have a text file called one.txt. So now we are going to open that file and read it. Read the contents. Okay. Right. Now, so to open a file, what do we do? See, we have a built-in function called open. And to that function, we should give the name of the file and the mode. So the mode is read, write, or append. Right? There are some other modes. We won't be needing those. Right. So now, just a small example. Okay, now, let's say I take my variable file and I'm going to open it. What was my file name? It was 1.txt. And I'm opening that file to do what? To read. Okay. So now we have opened the file. So now how do we read that file? Okay. So next, to read the file, there's another inbuilt method. So we use file.read. Okay. And let me show you how to do that. So this is quite easy stuff. We'll be going through this a bit quickly because there are some interesting and a bit thought-provoking things coming up in the session. Okay. Right. Sorry. Step. Okay. Now you can see that we've got the output of the file. Right. So the file had 1, 2, 3, and to the output we got what? We got 1, 2, 3. And I hope it's clear up to this point. If there are any questions, please feel free to ask them. And is it clear up to this point, everyone? Okay, seems okay. Right. Now we will be looking at how to write to the file. Okay, so here this is the difference between what? Append and write. Now I'll write to this. I first append to the file. Okay, I'll first show you what append does. Let me write say 4. Okay. Now let's see what the file is. Right. First, we need to go to a new line. Okay, go into a new line, and we are writing the letter 4. Okay, let's see if it works. Running to a small error. Let's figure out it. Put it down. Let's see if we can write to the file. Yes. Right. Okay. Right. So you can see that if we write to the file, the contents in the file are overwritten. Okay. Right. And if we append to the file, what happens is the content will be added at the end. Okay, so this is how you do it. Let's move on. And it's important that if you open a file, you should close it. So now here I'm opening the file, but I'm not closing the file. Okay, so you have to make sure that you close the file after you write. Right, so that is important. So we learn now three things you can do with the file. You can read, write, and open. So to read, you should give this file mode. To write, you should give this file mode, and to append, you should give write. This file mode. 1 second. Right. So now this is what you have to do with files. Okay, so it's a simple thing. Now we'll go on to the real section of today's session. Hi. Okay, now we are going to discuss some questions. We'll go from hard, so we'll go from easy first, then move on to harder questions. So now let's try to implement this. I'll give you some time to like read through the question and let's understand and try to do this together. Okay, right. So the question is, we have a coffee shop. Okay, so the file handling part, it's not relevant to this now. We can continue this. If you have any questions about file handling, we'll address them at the end. Let's solve some questions. Now let's focus on problem solving and let's continue with this. Okay, right. So we have a coffee shop and we have to create some program to calculate the final bill. Right. So there are some conditions first. But every drink, right? Every drink has a base price, right? Every drink has price, and some drinks are discounted by 20%. Okay. So now, how do we tackle this? We should implement a program that can be able to get the drinks a user want, then calculate the final bill and give it back to the user. Okay. So I'll give you like 2 minutes to like try to think of a way to do this. Okay. In the meantime, uh, I'll write my own implementation of this. Okay. Now let's try to do this together. Okay. Right. So they've given us this. Each drink has a base price stored in a dictionary. Okay. So this is our dictionary. Let's start. Let's try to solve this as we go. Sorry. We have something called drink prices. And it's what? It's a dictionary. So a dictionary has what? Key value pairs. Let's sum here. T is what? T is 350. Then we have milk. I'll add three. I'll add three of these. So, right. And we have other discount drinks. So I'll add milk. It's a list. Right. So what's the first step? Now here, try to note what I'm doing. First, I will write what I'm going to implement in comments in the form of comments. Okay. So this will be now plain English. What's the first step? Get the type of the drink, type of the order. Right? Say the drink order. We can system the slides. Right. Then what should we do? We can only calculate the bill if the user inputs what? A valid drink, right? So it should be either tea, milk, or coffee. So then we should check if the drink is available. Okay. Then what? If it's available, then we should calculate the price. And if we are calculating the price, we should account for what? There's a discount of how much? Discount of 20%. So 0.2. So what? Check the discount per drinks. Then at the end, calculate and print the row. Okay. So now we are doing this for one drink. Think we are implementing this for one drink. Okay. So we are getting one drink order, calculating the price and printing it. Okay. Right. So now I'll get the drink. How do we get the drink? Let's say enter drink. Okay. Now the user will enter string. Now I have to check what do I have to check? If the drink is available. So what does it mean? If it's available, it should be in this dictionary, right? So we should check if is in. What should we check? We should check if it is in this tea, milk, or coffee. So to get that, we can use something called this cheese, right? It's just we'll go step by step. So we'll just see if this is working. Okay, we'll enter a drink and see if that drink is available. Okay. Let's see here. Sorry. Uh, Type over drink prices. Let's not available. Okay, milk is there. Let's say green tea or something. So not available. Now this far it's working. It's fine. So what do we have to do? We have to check this case, right? If it is available, what should we do? Then we should now start calculating for the total. Okay. So I also have a variable to keep the total. Okay. Let's say between the price first what? Drink prices. So now this is a dictionary. Now I'll get the value in the dictionary drink. Then we'll have to check what? We have to check if that drink, we have to check if that drink is discounted. Okay. So in the same way, we'll do drink in what? Discounted drinks. I hope you're following. If you have any questions, just put it in the chat and we'll discuss them. Then, now the price gets discounted. So this thing we can write in Python a short form like this. Okay, so this means the same as this. I hope you guys are comfortable with equations like this, right? So what this means is, let's say the drink price is now 100. You apply the discount, so you multiply by 0.2, then it's what? Sorry, this. So you get a 20% discount. Now the price is 80% of the price. So if it's 100, you multiply it by 80%, then you get the right value, the new price, and you assign it back to the price. And we'll print the price. Okay. So coffee. So coffee is not a discounted milk, so we got 4. And then again, if you run it, give milk. So the discount is what? The discount is applied. Okay. Right. Now we have done this part. So what we have done is we have done the program just for one drink. Okay. But the customer should be able to get more drinks. Okay. So now we have to do the same thing over and over again. Okay. We have to do the same thing repeated. So to do that, so this is what we have to do something repeated. This is now a loop. Okay. We have to do something, the same thing over and over again. So this is how you identify. Now we need some loop here. Okay. Right. So we have to create a loop. So this is a special sort of loop, while through. So while through means this is now a while loop and it will run forever. Like this through means it will run continuously until you break out of the loop. I'll show you what I mean by break out of the loop. So while through is you have some logic inside the loop. Okay, this is our logic that's running. And unless you reach some conditions, you will keep on running forever. Okay. So, right. Now they have said that if you get if if the user input's done, so according to the question, if the user input's done, then you are done running the program. So that is where you break out of the loop. So if the user input's done, you know you have to break out of the loop. Okay. So now we see if drink is equal to what? Done. Then what should we do? Then break out of the loop. Okay. Break. Right. Then we check if the drink is in the available drinks. Okay. Otherwise, we will print out what? Drink not available. So this is just one way of implementing this. I'll show you another after I go through this. Okay. And here now we have one more problem. Okay, one more problem. What is that? So when we run through this loop, say you enter coffee, then you get the price, but you get the value of the variable price as 4. Then the next time you come to the loop again, that 4 is now not there anymore, right? After you come back in here, that price is now something else. So you have to have another variable to add up the total value, add up the value. So if you get coffee the first time, you should add 4 to that value. If you get milk the next time, you should add what? The relevant price to that value. So we have another variable. Let me call that total. And at the beginning, the total is what? The total is 0. Okay. Right. Then what should we do? We calculate the price, and I should add that price to what? To the total. Okay. Right. Right. This was very short. Yeah. You add that price to the total, and then at the end, let's print the total. Total bill is what? Right. So it seems good. Let us try it. We will no. And the total bill is the added amount. Okay. So this is a simple program. And do anyone have questions on this? Are there any questions? I'll give like 2 minutes for anyone to ask questions. If there are any unclear parts, let's discuss it. I know that there are some students here who can easily grasp this, and there are some like beginners to programming. So everyone, don't worry, you get better at this as you go on. So if anyone, I don't think there's anyone here who's finding trouble in understanding this, but if there is anyone who's finding trouble understanding this, don't worry. If you do this over and over like enough times, this will be like mundane task for you. You'll be able to do this naturally. Okay. Right. Seems like there are no questions. So let's move on to the new. Let's move on to a bit harder question now. And I'll show you another way to do this. Okay. Sort of a better way. Right. So here, this is like more fine detailed stuff. So here, see, we are writing this code. What we should try to do is always minimize the indentation. So see, here we are already inside the while. Okay, inside the while loop, again we write a lot of logic inside another if condition. So we have indented once, And again, another time we have come inside another indentation. Okay. So what we should try to do is minimize the indentation as possible. We can't get rid of it. We should minimize it. So how can we minimize this thing further? The while loop, we can't minimize it, right? We need the while loop. So the logic, it should run inside the while loop and we can't minimize it. So that's okay. But here we can do something different. We can do something like this. We can check if we can check the opposite. Okay? We can check if a drink is not in this. So if it's not in this, it's no point in calculating the price, right? So we just print the drink is not available, and then we again ask the user to enter a new drink. So to do that, what we are trying to do is we are trying to skip this logic down here and go to a new iteration of the loop. And we have this keyword to do that. Continue. Okay. Right. And if this fails, so if the drink not in drink prices fails, that means what? The drink is in the drink prices. So if we come out of this, if we come to this part in the loop, that means we have not continued. We have not gone to a new iteration. We are in the same iteration, meaning that the drink is available. Okay, we are doing the same thing. We are doing this, but in the opposite. We are checking if it's not there first and handling if it's there, the case that if it's there, second. Okay. So now I can get this inside. Okay. Let's try this again. Okay. All right. Small mistake here. My bad. Again. Right, we get the same answer as before. Okay. Right. And now we have reduced the indentation. So it's always better the key approach here. Okay. The basic logic here is before you perform any logic, okay, before you do something like this is the heaviest logic here, right? No, not this part. It's just one check here. Before you perform this heavy logic, okay, you should try to check the failing cases. See, if the drink is done, no need to perform the logic. If the drink is not available, no need to perform the logic. In some other problems, we might run into other cases. Like if you have to calculate a total bill, and if he's asking, let's say he's putting some nonsense values, not done, and not something like this, he's putting some numbers, so sort of things. So you have to check those first and cancel out. And if only he enters the right inputs, you should perform the heavy processing stuff. Okay, right. So remember that tip for your future. Right. Now let's go to a new question. Let's see. Let's go to a new one. Right. I hope everyone is good with that. Now we are going to move mathematical stuff. So now this is getting interesting. So let's just understand the question. Let's take it slow and let's understand the question. Goldbach's conjecture. So Goldbach is a mathematician and he has many like theorems, conjectures. So this is one of his conjectures. Okay. His conjecture is one of mathematics' oldest and most famous unsolved problems. So it is a conjecture is something that's not proven yet. Okay. We can validate it. That means we can check if it works, but we don't know how or why it works. That's what the conjecture is basically. It states that every even integer greater than 2 can be expressed as the sum of two prime numbers, right? Every even integer greater than 2 can be expressed as the sum of two prime numbers. So what's our question now? Implement the Python program using functions. Okay, functions. Now we will get into functions. Okay, there's a small question: how to get the price for the discounted drinks? Okay, right, right. So let me explain it this. Say the price of a let's say Kit Kat is 100 rupees, and on one day you have a 20% discount. Okay, so what is a discount basically? You subtract some amount of the total value. So I'll just rewrite this formula. So let's say the in first price is what? The first price is the original price. Is, um, let's say my price is now 100. Okay. Now this is now all max. If I get a 20% discount, so what is the value of the discount? 20% means what? X into what? X into 20 divided by 100, right? That's 20%. So if I print D, what's D now? D is 20. Got that, right? So this is the discounted price. That means from the original price, 20 is being removed. That means what? X is the new value of X is this, right? 80. So now I'll write this entire thing in one equation. Instead of D, I'll write this. So now X is what? X minus X into this thing I'll write as 0.2 or 0.2. Right. Now I'll put this 0.2 into a variable discount. Okay, now what's my equation? X minus X into discount. Now see, X is like common, right? You can factor it out. You factor it out, what you get is this X into 1 minus discount. So the new price is what? X equals X into 1 minus discount. And in Python, you can change this. There's a short form, right? This. What's the short form? This is the short form. So that's how you came up with this. See, price. So price here is X here. Price is times into equals 1 minus discount. Okay, it's the same thing. So now it happened 2 times. Right. Is it clear? The person who asked the question? I hope it's clear. Yes, very good. Right. If you have any questions like that, ask, okay? Right. Now, let's again come to this question, goal box conjunction. Every even integer can be written, every even integer greater than 2 can be written as a sum of two prime numbers. Right. So in this question, there are a lot of sub problems to solve. First thing, how do we identify if what a prime number is? Okay, so for example, let's think of a number like 10. Okay, now if the number is 10, put in the chat different ways you can write it as a sum of two numbers. For example, 10 is 1 plus 9. Put into the chat some other ways you can write 10. Quickly. Two or three will be okay. Come on, guys. So yeah, I have what, 2 plus 8, 3 plus 7, 4 plus 6. Okay, nice. So all of these are what? All of these are different ways to write 10 as a summation of two integers. But what we need is, let me write it. So 10 can be written as uh, 10 can be written as what? 1 plus 9. So this subject is something called partitions. Okay, if you want to study further, there's something called partitions. Different ways you can break a number, and so on and so forth. And this is what we are looking for. See, both the numbers are prime. Okay, but the computer doesn't know what a prime number is. Okay, the computer doesn't know what a prime number is. We should tell the computer some way to identify what's a prime. Okay, so inside this question, we have a number of tasks. First one, we should identify what? Different, like two-digit summations. So two-digit summations, right? That's one task. Then we should check if both numbers are prime. Okay, so we can have we can have multiple partitions, but only some will be prime, right? So how do we tackle this problem? It's a bit of a harder problem. So see, these things, these sub problems we have to solve. They are not simple problems. Like if say x equals a plus b, that's just one line, right? A plus x equals a plus b. So you don't need a separate function to write. So it's just one line. But if this thing, let's say check if a number is prime. It is a problem, but it requires many lines to solve. But that is not the main problem. That is some sub problem of a bigger problem, but in itself is quite a large problem. So to solve these type of things, we use what? Functions. So functions are what? Solutions to small like sub problems like this. How we solve sub problems like this. Okay. Now before going into this, we'll use the same thing we did here. Okay. We'll convert this into a function. Okay. So then it will be easier for you to understand how functions are written. So in Python, we use this keyword called define. The word is define, the keyword is define. Let's define a function called calculate price. Calculate price. Okay. Then what do we give it? I'm going to try to write this code here. Then drink prices, this is a global variable. So this drink prices is defined for everyone to see. So just need to give it the drink and to be good to go. So now what I write here is this, just this. Okay. Let's see if it works. All right, sorry. Let's keep the total as well. And then total. Right. Okay. Now where did I go wrong? Okay. Let me there were some errors, but just keep on looking for now. So what we are doing is we are doing the calculating part. What is the calculating part now? We have to check if the drink is discounted, we apply the discount. Otherwise, you just return the price. Okay, so this is the price. We calculate the price of the current drink. Okay, we try to calculate the price of the current drink and we add it to the total. Then we print the total. So that's what I'm doing. Done. You get the same result. Okay, but here, so in our main while loop, we only have this now. We have taken out that complex implementation to somewhere else. Okay, so that's the same what we'll do with the next program. It's the same thing we'll do with the next program. So first thing, let's first identify how we can identify prime numbers. So that's our first goal. So is prime. We'll give it some number, let's say n. Then this function should be able to identify if the number n is the prime number or not. Okay, right. So how do we do this? So now we have a small part of maths. Okay, try to understand this. If you don't understand this, it's okay. Say now, what is a prime number? Prime number, let's for example take 5, and I can write the factorizations, right? This is the only factorization I can write down for prime numbers. Okay, then if you say 8, this is not a prime, so you have many factorizations. That's okay, that's fine. Now, think of this. How can I see this? Consider this number 25. Okay, it is a square number, and we have what? We have factorizations 1 into 25 into 5. Next factorization is again 25 into 1. Okay, so see, if you like keep incrementing this side, say 1, 5, 25, this side keeps like decrementing, but you get the same values, right? After some point, you get the same factorizations. So the factors are 1, 5, and 25. Okay, but to get this, right, to get all of these, it's enough if you only check up to this level, right? You don't have to check this. You can check up to the square root. Okay, now this is an important observation. We can use this to check if a number is prime. So how are we going to check a number is prime? Let's say we have a number n. And what we'll do is, we'll keep on dividing this number by primes that are less than this number. Okay, so first, what at the start, the primes we know are this. Let's say the only prime we know is 2. Then we get the next prime. Then next number. What's the next number? 3. So if we can divide 3 by 2, then it's not a prime, but we can't, so it's a prime. So we add 3 to this new list, and we keep on doing this to get the number, to get the numbers, get the prime numbers. Okay, right. Let's discuss this more while we write the code. Okay. First, but we can only check if the number is prime if it's greater than 1, right? So if it's not greater than 1, we don't have to do anything. Just return it's not prime. So what this function will do is, if it's prime, it will return true. If it's not prime, it will return false. So if the number is less than 1, It's not a prime, return false. Okay. Then now we are going to do what? Check if the number is divisible by smaller numbers. And we only have to check this up to its square because of what I explained. Okay. Right. So now, right. We start from the first prime number, which is 2. Then we have to go up to what? We have to only go up to the square root, right? So square root here, and we'll increment by 1. We'll keep on going by 1. Right. And there's a small like programmatic detail here. The range function, the what we are using, the range thing here, can only get integers as arguments. So here, consider a number like 20. It doesn't have a perfect square root, right? So we won't get the integer number here. So what we have to do is, we have to convert this number to an integer. Okay. All right. Then we check what if this number is divisible by the number we got here. So what will this I be? It will be something like 2, 3, 4, 5, 6, so on and so forth. And if this number is divisible by I, okay, that means what? It is not a prime. It is divisible by another number, smaller number. Okay. Yes. Right. Then it is also not a prime. And we'll do this thing until we reach the square root. Okay. Then if we come out of this loop, that means we have passed the square root. That means no smaller numbers can divide this. So this is in fact a prime. Okay. Right. Now let's see if this is working. Let's get a number. It's prime. Just keep on printing. Let's put a 7. It's 1, 26. Okay. So the first answer would be true and second answer would be false, right? Okay, true and false. It seems to be working. Now, right, we have a suggestion. Shouldn't we put +1 for the upper range? Yes, we can do +1. Doesn't make much of a difference, but to be accurate, yes, we should put +1. Right, thank you for that, Malik. Good. Okay. Now we have a method to check if it's prime. Okay. Then what shall we do? So our target is to find 2 additions using prime numbers, right? Okay. Then we have to calculate the primes and store them up to the number that we, let's say if you give the number like 26, if you get the number 26, we should first get the primes that are less than 26. That's our step one. So to do that, we'll use this is prime thing. We get the numbers that are less than 26. Then we use those numbers, right? We use those numbers to see if we can come up with the two-digit summation that equals 26. Right. So then we need another function to do what? To get the primes. Say generate primes. Okay. Up to somewhere. So to do this, we'll use something called uh, we'll use something called C of Eratosthenes. Okay, the name is a bit hard, but see what they're doing here. First, we know 2 is a prime, right? Then what we do is we have a list of all the numbers we need. So if n is 120, we take a list of the 120 numbers. And then we remove all the multiples of 2 first from the list. Okay, then we get the next number. So the number that's remaining is what? A prime, right? Then we use that number to what? We add that number to the list again. And remove all the multiples of that from the number list. And we keep on moving. So the numbers we get are what? The numbers we get are all primes. Okay? Right. So right. I hope it is clear. Okay. This animation is clear, right? No, break is not minimal. The break out. Right. So the breaking thing is this is a function, right? So a function is something. It's a good question. Let me explain that. So a function is something like this. Think of a function as a box. So you give it inputs and you get outputs. Okay. And inside you have some logic. Right. So inside this logic, we can have places that we can go to the output. See. So this thing is done using this return keyword. So if you want to stop like further processing, like we did in the break, using the break in the loop, okay? So here, if this is the case, we should what? We shouldn't do anything further down and we should return from the function. We should break out of the function. So that's what's done using this return false, right? So this is what's breaking out of performing this, like the below logic. I think it's clear now. Was that the question? Yes, okay, nice. Right. Right. Let's do this another way. Right. First, I'll have the numbers. Okay. All the numbers that are starting from 2 up to the number we need. Then what we do is we have points. Right. Then what should we do? We should get this 2 and remove all the numbers that are multiples of 2. Right? So how do we do that? Mhm. Let's something like this. Okay. Right. We can do something like this. First, um, we'll create a number like a list of two values. Okay? So first something like this. We think everything is prime. Then we remove the things that are not prime. Then we are left with the things that are really prime. Okay. So that's the logic. So at the start, this is what we have. Then you remember, right? We only check up the square root. While p is less than or equals the square root of okay. What we'll do is so if the number we are having is a prime, so if the number 2 is prime, what we'll do is uh, so now p is a prime now. Make it true now. If prime p is true, so that's the case we get if we are inside this if condition. So if prime p is true, then what to do is we have to remove all the multiples of what? The prime p. Okay. Then this point, then start from that number. Okay. Then we move to the next number and we keep on doing this. So think like this, what's happening is here. So first 2, then you go from 4 onwards, you remove all the prime numbers. So 4 is 2 squared, right? Then you remove all the prime numbers from 4. Then 3. So if you take 3, we should remove all the prime numbers starting from 9, right? See, 3 now, then you get go to 3 squared and remove all the, like you move from steps of 3 and remove all the multiples of 3. And you repeat the process. Okay? Right. Then, now this is just a list of true or false values. Then we have to have the numbers, right? List of numbers. So the list of numbers is what? We plus 1 if this is true, then what? We have numbers list, then numbers append to that list. Okay, so let's see if this is working. Right. බලමු. No, that's not the case. So here now we are using this method, right? So we don't actually need this uh, is prime here because we are following this method. So see, like what we are doing is we are taking the multiples and removing them, and what we are left is ultimately the primes, right? So if it was a multiple somewhere, it should be removed. Okay, so now the problem is oh, shows give me a second. Put here, yeah. I did correct that. Wait. Now give me a minute. Right. Okay. This is right. So, it's right. Sorry. Okay. Right. So what's happening is this again. Let's just we have to go through the algorithm what we're using. Take a number from starting from its square number, remove all the like after 4, go by steps of 2 and remove all the numbers. Then go 3, from 9, go steps by 3 and remove all the numbers. Okay. Then what we are left is with the prime numbers up to the number we need. Okay. So now we will use this later. So this is enough for us to get the numbers, the prime numbers up to a certain way. Then we need to check if the number is a Google. We have to get the Google bar. What Google bar? Two prime numbers, right? We have to validate if it's true. So now let's get a number. Okay, then what we have to do first is we have to get the primes up to that number. Okay. Right. So this will get us the primes up to that number. Then what should we do? Now we should go through this list and primes. We have to check. First, let's check if the number is even. Then it's not even. And is less than plus 2. Okay, then false. Then we should check if we can add this number up using prime. Okay. If right, then we check Yeah. So if P is in prime and the other number, say we have to find two numbers that add up to n, right? So if P is a prime number and we also have the other number, n minus P, also in the prime numbers, then we have found a method to, get the number n using two primes. Okay. Say done. Otherwise, done false. Then let's see number. So what should we get? For this, we should get true, and for 23, we should get false. Okay, let's see if it works. So for 6, we get true, 23, we get false. Okay. So this is prime, this thing, we will get to use it further. So in next problems, coming up problems. But right now, we don't need that because this generate primes thing using that sieve of Aristotle's logic, we can get all the prime numbers that are less than a given number. We don't need to do this. Okay. Right. So if you need to check if a number is prime or not, we can use this method. Right. Right. Let's go back and get back into problem solving. I don't think we'll be able to cover everything, so we'll cover important problems and we'll move on with the rest. Right. Okay. Right. Guys, now let's move on from the competition question. We got so many answers. The winner will be announced at the end of the session. Right. Now let's go back and solve some more questions. Right. All right. Now we will try to do this. Here we will be able to use that is prime function to validate if a number is prime or not. So I'll just will give you the source code, I think. So it has all the answers, and I'll briefly move through the ways we can solve these questions, and then you can go through the source code and implement them yourselves. And we'll discuss one important question that should be discussed for you, which is sort of a hard question. We'll get to that and spend some time on trying to implement that because it's a hard question. For the others, we'll try to I'll try to give you a brief understanding of how we do this. Okay. So this is quite an easy question. Okay, we have to identify if an image is a rectangle or a triangle, and if it's and calculate its area in the correct way. Okay. So here we'll be we'll look at something called default values for arguments. So here, so this is a normal function. This similar to what we wrote a few minutes ago. So these are the arguments, and then this shape is also an argument, but we can give it a default value. So a default value is something like if you don't give any value to the shape when you are calling the function. So if after you write this code, somewhere in the code below you call the function get area with height, and without the shape you call. So something like this. After writing the function, you call it the code, right? 10, 15. This only you provide only the width and the height. You don't provide the shape. So in that case, Python will consider this shape to be this rectangle or react. Okay. So that's what's meant by a default value. But if you do specify something like this, then it will consider the shape to be the argument to be this triangle. Okay. So that's what we mean by default values. Right. So that's what's covered in this question, a small detail. So let's try to option. So both these problems, I think you'll be able to try if we are giving the source code to you. Right. Now this is the Bomberman question. So this is the most important part of our session today. So let's pay attention to this and let's consider this now. So we say Bomberman lives in a rectangular grid. Each cell in the grid either contains a bomb or nothing at all. Each bomb can be planted in any cell of the grid, but once planted, it will detonate after exactly 3 seconds. Once the bomb detonates, it's destroyed along with any of its 4 neighboring cells. Okay. So if the bomb is here, the neighboring cells they are listed as up down. So I j minus 1, j plus 1, and I plus 1, I minus 1. So there are like altogether 5 cells, essentially across. Okay. So all the bombs, and if a bomb detonates, it will destroy everything in its neighboring cells and in its cell. Notice if there's bomb in the neighboring cell, the bomb is destroyed and not detonated. That means there's no chain reaction. So there are 2 bombs in neighboring cells. If this detonates, this is destroyed. This doesn't detonate and destroy its neighboring cells, and no chain reaction, not that so. Okay, I hope it's clear. I'll give you 2 minutes to again understand the question scenario. Then we have process that this Bomberman guide us. Okay, first there's the initial state now. A state where the bombs are planted at the beginning. Okay. Then after 1 second, Bomberman does nothing. So first second, Bomberman does nothing. Then the next second. So the second, Bomberman plants bombs all cells without bombs, thus filling the whole grid with bombs. Now, in the second side, we have an entire field of bombs. Okay, no bombs will detonate this. And in the third second, the bombs that are planted 3 seconds ago will detonate. And Bomberman just waits and sees. Then, what's the fifth step? He repeats 3 and 4. So 3 is filling the bombs, filling the cells without bombs with bombs, and then watching them detonate. So it does the same. Okay. Now there's a pattern here. So if we see the pattern, we'll be able to easily solve the problem. Right? So now let's try to understand the pattern here. Okay, we get a whiteboard. So I'll just clear my drawings. This is initial explanation I just wrote earlier. So just think we have, this is the initial configuration, okay? Something like this. So zeros are bombs, dots are no bombs, something like this. So this is S, what? S0. So initial configuration. S1, what happens? Nothing happens. So this is S1 also. Then S2. Okay. S2, he fills everything with bombs. So you have entire field of bombs. Yeah. Now in S3, what happens? In S3, these cells detonate, right? So there will be no bombs in these locations anymore. This, 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 and this, and this. So we have bombs. We have it align this. We have bomb here. Here, no bomb here. No bomb here, no bomb here. No bomb here. We have a bomb here. Bomb here. Bomb here, no bomb here, no bomb here, bomb here. Right. Again, in S4, what happens? Repeat step 3. See? He repeats step 3. So it repeats step 3, which is fills everything with bombs. Just copy this. It fills everything with bombs again. And then in S5, okay, S5, what happens? Now these stop detonate, okay? These bombs. So if I say this is like a, say, configuration bomb 1. Okay, first time bomb 1. The second time, so this is now bomb 2. Bomb 2, what happens? These things detonate. This is not a bomb here, a bomb here, no 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 bomb here, bomb here, bomb here, bomb here, no bomb here, no bomb here, no bomb. So again, we have this configuration, a new configuration now. Again, in S6, what happens? We have the same configuration. So this is now what? This is what? S6. Okay. This S6. Now S6 is fine. Okay. Now again, let's observe what happens in the next detonation. So this is where you have to pay attention. This is going to detonate, right? So no bomb here, no bomb here, no bomb here, no bomb here. No bomb here, no bomb, no bomb, no bomb. Bomb here. Bomb here, no bomb, no bomb, no bomb, bomb. This is now S7, right? Do you see that? This and this are the same, right? Yeah. So we have essentially come to a repetition. Have this cyclic repetition. Okay. Let's try to understand why this thing happens. Okay. So say you have this, you have at the start, you have all bombs. Okay. Then you pick some bombs randomly to explode. Right. Now I'm going to draw dotted lines on the neighbors. Okay. The neighbors. This have neighbors. This. Right. Now these guys are common to what? This neighbor, these cells are neighbors of both this and this. Okay, this is now not a chosen cell to determinate. This is important. This is a chosen cell to determinate. Okay. Now this is chosen cell to determinate. This is not. Okay. That's the important point. So these neighbors will always be determined. Like because they are destroyed, right? They will be destroyed. Either this detonates or this detonates, this will be destroyed. Point is, when this detonates, the crossed cells detonate, these things will remain, right? Then what will detonate in the next time? These cells, right? The remaining bombs. Then when they detonate, what will happen? Them, these bombs and the neighboring cells will remain, and these cross guys will. So sorry, these bombs and the neighbors will detonate, and these cross guys will remain, right? So that's why we have this cycle. When the cross guys detonate, the neighbors anyway gets destroyed, but these guys will. So these guys will. And the next round, see, when these guys detonate, they and the neighboring guys get destroyed, but the cross guys should. Again, we have something. So we have altogether 4 configurations. First one is what? S1, the initial configuration. See, it's not what's getting repeated. Okay, that's not always the case. We have S1. Then we have all the even states. All the even states. Right? All the even states. Then finally, we have 2 more states. What are the 2 more states? Yes. So let's try to come up with a general term for this. 3, 7, what? They are going in 4s, and they're just 1 less than 4, right? So then we can have something like 4n minus 1. Okay, otherwise you can say 4n plus 3. So n is going what? N is 0, 1, 2, 3, so on and so on. Other thing is what? So we can also write this. Okay. Now we can't really check this, right? We can't really check if it's difficult to check this like when you have 4. So another way to write this is if n, so 3 plus 1 mod 4. So that means if 1 plus this number divided by 4 is 0. Okay. So what is this number? It's 5. If let's say 3 plus this number mod 4 is equal to 0. So these are the 4 categories. These are the 4 categories. Let's see how you can go about and implement this. Okay. Right. Let me share my. Okay. Implemented code here. Right. So let's just look at problem again. Okay. Now, so this is like a proper problem description. So we have what? We have this is what we get in my Capella completions. Okay. So we have a function description. So what is function description? This describes what you have to do. Okay. So you get what? You get the input format. You get these inputs in the way they have said. So the first line contains 3 space-separated integers R, C, and N. The number of rows, columns, and seconds to simulate. Okay, so N is the number of seconds to simulate, R is the number of rows, C is the number of columns. Each of the next R lines contains the row of the matrix as a single string of C characters. The characters are either a dot or a zero. Okay, so now we have adhered to this input format and do our program. Okay, we have to write our solution, assuming that this is the format they are going to give. Okay, so that is why they're giving this input format for us. Okay, right. Now let's try to understand the code. Okay, so you guys see the code. So first, let's go line by line. Now this line, what it does is it takes the input. Okay, it gets the row column, the format that they have seen. RCN, space separated integers. So we get the RCN. Then this B is used to get the initial configuration. They have said that we have an initial configuration of blocks. So that is this B is that. Okay. So right. Now this B gets the initial configuration of blocks. Okay. And then we have two cases. So we had four cases, right? B will have the initial configuration. So if n equals 1, if we have to just simulate 1 second, then what will have? We'll have the B. So this is just printing the configuration out in the form of a string. It's just like syntactical, uh, syntactical stuff. But the four states are this. This is one state. So this is all the even states, right? This is all the even states. And this is another state. This is the initial state. Okay, this is the initial state. And then we will have another state. So what is the other state? We have even states. So all n divided by 2 is equal to 0 is initial states. And so n mod 2 equals 0 are even states. Then if we like consider as a 4, we have 0 and 2 1. So we have what n plus 1 and n plus 3. Right? Just thinking about modular arithmetic. So n plus n mod 4 equals 0 and n plus 2 mod 4 equals 0 are both in this. Okay, right? Okay. So then we have n plus 1 mod 4 and n plus 3 mod 4. So 1 is what? N equals 1. That's the initial configuration. Okay. Then we have n plus 1 mod 4. That's n plus 1 mod 4. Okay. So this we get bond 1. Okay, I'll explain how we get bond 1. The other one is bond 2. Okay. Right. So how to get bond 1 is you just have to simulate what's happening. So we have a bomb state, let's say B. Then we fill the bombs with bombs. Then this the other state. So initial state, fill it. Then the other state is what we are getting. This is the state we are looking for. Okay. So here B, this function B refers to the initial state. Okay. Then you fill it with bombs. So this is what this field variable has. Then you just do what they say. If ij contains a bomb, then all its neighbors and its are now destroyed. Split it with dots. Then that will be our new state. So we know that there are two states, two configurations that keeps on repeating. What? S3. So this is S3 now, bomb 1. So and for bomb 1, we give it the initial state, initial configuration. And for bomb 2, what happens? The initial configuration will be bomb 1. So S3 comes from S1, S5 comes from S3. So then S3 and S5 keeps on repeating, right? So that's the whole idea. Okay. So bomb 1 and bomb 2 is calculated that way. And now we know that these things repeat. So this will give you the correct answer. Okay. Right. So yeah, that's it. So I'm sure that they will you can get the slides and the source code for the problems. So you can even go on as well, like having time constraints here. You can go on like study the last questions, the ones we skipped over in your own, and there are online resources as well. You can refer there, and you should always try out more questions on platforms like HackerRank. There are platforms like LeetCode, and so many other platforms where you can try out competitive programming and become better at this. You have to do it repetitively to become better at this. Okay, so this is something that requires practice to be better. And as you can see, like I'm also struggling sometimes because I've also been lacking some practice. But if you have the practice, you will be able to see things very quickly and see what's going on, what is the underlying problem, and then come up with the solution fast. So that's what's important when it comes to competitive programming. You have to be quick in like identifying the problem and identifying the possible answers to that. So this session won't give you that much, but it will like show you the direction to go towards. So I think we will have to wrap up now considering the time constraints. So you can go over the source code and these presentation slides and try the other problems as well. And there the one more thing to point out is that you'll have a few dozen possible solutions to solve a given problem, right? And among them, there are better, always better, and like maybe best solutions. So you should always try to get to the best solution, right? So this is called finding the optimal solution. So you can get a solution at first, but it might not be optimal. And on most of these competitive programming sites like HackerRank, they have put a time limit to your solution. So if your solution is not very optimal, most of the times it will fail that time constraint. So for you to pass the test cases and pass the time constraint and solve the problem correctly, you should come up with a more optimal solution. So there are some problems here that give you ideas of optimization. So you go through these and identify better ways to solve a problem. And yeah, I guess that will be it for this session. And if there are any questions, I'd like to give this time to raise them. If you have any questions, put it in the chat. Yeah. So those are the points that I'd like to point out when doing competitive programming. Right, as now as we have reached like you are gone like 10-20 minutes beyond the scheduled time also. So now let's wrap up this meeting. Thank you everyone for joining. Thank you for the organizing committee for organizing such a good event to educate the interested students in these subjects. And I think you got some valuable information from this session. And pardon me if I made some errors when teaching you. I hope you got some valuable information that you can use in the competitive sessions that are coming up. And also good luck on the contest. I hope you do your best. So practice and use these tips and things you learned in this session to your benefit. And I hope you do well in the competition. So guys, good luck and until next time, hope I see you again. Good night.